In our last video, we watched the moment where curiosity turned into quiet disbelief. You could almost feel the shift, like the ground beneath modern science had started to move. Tonight, we're picking up right where that story left off, because what the Webb telescope is uncovering now doesn't just challenge our theories, it stares straight into the idea of where everything truly began. What Webb is revealing has left even seasoned scientists wide-eyed. The early universe is opening up in ways no one fully expected, hinting that something may have existed before the Big Bang itself. Even Nobel Prize-winning physicist Roger Penrose has described these discoveries as overwhelming, suggesting our universe might not be the first chapter, but just one page in a much bigger cosmic book. The evidence Webb is gathering is shaking the foundations of modern cosmology. We're talking about a mysterious black hole that could be linked to a previous universe, colossal structures that shouldn't exist according to our models, and a galaxy that formed just 90 million years after the Big Bang, far earlier than anything should have had time to grow. Together, they raise a haunting question. What if the Big Bang wasn't the true beginning at all? Some scientists now wonder if the universe doesn't really begin or end, but instead moves through endless cycles of creation and renewal. We often imagine the Big Bang as everything exploding outward from a single point in empty space. But here's the twist. There was no empty space back then. There was no outside for anything to expand into, which makes the whole event almost impossible to picture. Physicists describe that first moment as an unimaginably hot, dense state. Try to visualize it, and your mind quickly hits a wall. You might imagine the universe as a tightly woven fabric where everything overlaps, but even that image can mislead, because it suggests a center, and the universe doesn't actually have one. Instead, the universe expanded everywhere at once. Not from one place, but from all places. It's like asking, how can something expand if it's already infinite? The answer is strange and beautiful. The universe didn't grow into something bigger, it stretched within itself, across all of existence at the same time. As space stretched, tiny ripples formed in the invisible quantum fields that fill the cosmos. Those faint disturbances became the seeds of everything, matter and energy appearing everywhere, all at once. This wasn't an explosion in the usual sense. Nothing was flung outward from a central point. Reality itself simply switched on. Picture an endless box where particles suddenly start forming throughout the entire space at the same time. That's closer to what happened. At first, it was far too hot for atoms to exist. It took hundreds of thousands of years for the universe to cool enough for the first atoms to finally come together. And while all of this was unfolding, there was another hidden side to the cosmos at work, what scientists often describe as a kind of shadow or mirror universe, where dark matter lived. Even before normal matter could settle into atoms, dark matter was already clumping together. Those invisible clumps carved deep gravitational valleys that pulled ordinary matter toward them. Gravity became the great architect of the early universe, gathering material in dense regions while the expanding cosmos thinned things out elsewhere. From those first clumps, the universe's earliest stars were born. Massive, unstable giants that burned fiercely and lived fast, lighting up the darkness before quickly fading away. And in their brief, brilliant lives, they helped shape everything that would come next. As those first massive stars reached the end of their short, blazing lives, many of them collapsed in on themselves and became black holes. Over time, these growing giants began pulling in everything around them, gas, dust, and wandering matter, slowly building the foundations of the very first galaxies. But these early galaxies didn't look anything like the graceful spirals and smooth ellipticals we see today. They were small, lopsided, and messy. The young universe felt crowded and chaotic, more like a cosmic construction zone than the elegant night sky we're used to. As billions of years passed, dark matter and gravity kept doing their quiet, relentless work. Galaxies crashed into each other, merged, and grew. Little by little, complexity emerged from the chaos. And nearly 14 billion years later, we ended up with the rich variety of galaxies that now fill our universe. Here's the incredible part. We don't just imagine this history, we actually see it. When telescopes look deep into space, they're also looking back in time. The light from distant galaxies has been traveling toward us for billions of years, carrying a snapshot of the past. But that journey isn't simple. As the universe expands, the space the light moves through stretches too, draining energy from the photons and shifting them into infrared. That's why the Webb telescope was built to see in infrared, to catch the faint, ancient glow of the earliest galaxies. And that's where things get strange. Webb has found galaxies in the early universe that look far more developed than our theories say they should be. According to the standard Big Bang model, these early systems should be small, clumpy, and just getting started. Instead, Webb is spotting galaxies with clear spiral shapes, enormous mass, and in some cases, sizes rivaling or even surpassing our own Milky Way. Even more surprising, many of them are forming stars at a breakneck pace, far faster than most galaxies today. It leaves scientists asking, how did dark matter and gravity build something so complex, so quickly? Some of these galaxies appear at a time when, by our current understanding, only the very first stars should have been flickering on. One of the most talked about examples is a galaxy known as Capo de Monte C. Its redshift suggests it existed just about 98 million years after the Big Bang, a moment when the universe should have still been in its cosmic infancy. Yet there it is, already looking far too grown up for its age. This is where some bold ideas come into play. Physicists like Roger Penrose have suggested that our universe's story might stretch beyond the Big Bang, that what we call the beginning could actually be the continuation of something older. There's no solid proof yet of a previous universe, but Webb's discoveries are giving scientists plenty to think about. One clue comes from a supermassive black hole that appears far too big to have formed from the first generation of stars alone. To explain it, researchers are exploring two radical possibilities. One is that huge regions of matter collapse directly under their own gravity, skipping the normal star phase entirely. The other is even more mind-bending, that some black holes might be primordial, formed in an earlier universe and carried over into ours. Penrose has also pointed to the cosmic microwave background, the faint afterglow of the Big Bang, as a possible place to look for fingerprints of a previous cosmic era. Some recent studies suggest there may be unusual patterns in this ancient light that don't quite fit with standard models. And then there's the expansion of the universe itself. A few observations hint that it might be slowing down. If that's true, it raises the possibility of a future Big Crunch, where everything collapses back in on itself. And if that can happen in the future, could it have happened before? On top of all this, scientists are finding gigantic cosmic structures, vast regions of matter stretching across billions of light years. According to the cosmological principle, the universe should look smooth and uniform on the largest scales. But some of these newly discovered structures are so enormous they blow past that supposed limit. One massive arc, for example, spans more than 3 billion light years, far larger than what our models say should exist. So how did something like that form? With every new discovery, more researchers are starting to wonder if the idea of a cyclic universe might explain what we're seeing, a cosmos that doesn't start and stop, but moves through endless phases of birth, expansion, collapse, and rebirth. This isn't a new idea. Long before space telescopes and background radiation maps, philosophers and ancient cultures were already imagining a universe that lives in cycles. Some traditions spoke of cosmic ages, where the universe appears, fades away, and then returns again. Ancient Greek thinkers described a periodic destruction and renewal of everything. Certain Buddhist cosmologies talk about world systems that expand and contract over vast spans of time. Across cultures and centuries, the same idea keeps resurfacing. Maybe the universe doesn't have a single beginning. Maybe it doesn't have a final ending either. Maybe it simply keeps going, forever changing, forever returning. And with every new image from Webb, it feels like we're getting just a little closer to finding out. That's where we'll leave it for today. If this journey through the cosmos sparked your curiosity, drop your thoughts in the comments. We'd love to hear what you think.